Okay, so if you weren't able to finish lesson 5 in class, you're going to be doing it right now. These are the notes. If I go too fast, remember you can always stop, go rewind, listen to it again, re-listen to the whole thing. All of those things are an option when it's on recording. So today we're going to solve proportional relationships. So we need to know what a proportion is. I like to start from the very beginning, remembering what a ratio is, okay? So a ratio is a comparison of two numbers by division, okay? I'm going to make that a little bigger. And then a more specific ratio is called a rate. A rate is a comparison of two numbers that can be measured. And then we got into unit rate, which was a comparison of a number to one unit. Unit rate is over 1, remember that? Okay, and now we're talking about a proportion. A proportion is an equation that states that two ratios are equal. And because a rate is a more specific ratio, that would be the same thing. So what we're talking about is two equal ratios, and it creates a proportion that can be solved. So before we start, let's talk about determining whether a pair of ratio forms a proportion, and we can use cross products to decide that. So first, let's find out the unit rates of each of these to prove if they are indeed equal ratios. So unit rate, remember unit rate is over 1. So we start with a rate and we divide it to make a unit rate. Do you think you want to know how many hours it takes for 1 inch of rain to fall? Or do you think you want to know how many inches of rain fall in 1 hour? Just logically, what makes more sense? I hope that you said inches of rain over hours. That's typically how it's measured. We've been hearing a lot about rain the past couple of years, actually, and even in the hurricane that was just down south, how many inches of rain per hour fell. I think they actually measured that one in feet. So here we're going to take this and we're going to say, okay, if 5 inches fell in 2 hours, I'm writing this really big and it's super messy. I know what I'm going to do. There we go. Maybe I can make this better. It's a little tip for you when you get to 8th grade math. Make it big, because then it's a little bit easier to write on. 5 inches in 2 hours. Oh, that does make it easier. And this comes out to be 2.5 inches in 1 hour. That's kind of a lot, actually. Okay, 2.5 inches an hour. All right, let's try another one. I'm going to do this one in blue in case they kind of run together. 7 inches. Come on, machine. 7 inches in, I don't know why it won't write. I can do this. I'm sure I can. I'm on my Chromebook if you can't tell. In 2.8 hours. So 7 divided by 2.8, again, this is a decimal, is 2.5. Honest to God, I am trying to write on this. 2.5 inches in 1 hour. Then when we get, so we do have a constant unit rate, and now that we know that those are the same unit rate, I can actually take these ratios and prove to you how you can determine if they're proportional or not. if I were able to write on this, okay, I'm going to try and do this with my finger. Maybe it just doesn't like my stylus, which is very unusual. Okay, so I'm going to prove this. I'm going to do inches of rain over hours again. So inches over hours. Okay, it's working better with my finger. Very weird. So 5 inches in 2 hours, we're saying is the same as 7 inches in 2.8 hours. And we're saying it's the same because we know their unit rates are the same. So we're going to cross multiply. We're going to start at the bottom and multiply. Oh, that's not what I wanted to do. Multiply across and up. I don't know why this thing hates me, but it does. Okay, like this. So that's 14. And then we're going to start at the bottom and multiply across and up. 2.8 times 5 is also 14. So what I'm showing you is that you can use a proportion to cross multiply to determine that they are the same unit rate. This helps us when we have an unknown, like we do here, because I'm going to take one of those ratios. I'm going to take 5 over 2. 5 over 2. And remember, inches is on top and hours are on the bottom. And I'm going to take x inches in 6 hours. X inches in 6 hours. So now if I cross multiply, because I know up here that if they are equal, you can cross multiply and it will come out to be the same ratio. I'm going to say 2 times x is 2x, and I'm going to set that equal to 5 times 6, which is 30. And then I'm going to use algebra to get that x equals 15. Where was your x? It was in the numerator, which is inches. So this is 15 inches. So that's how I could determine that 15 would go in that spot on the table. So it's a lot of different things happening, proving the same thing, but also proving to you that this method of cross multiplying to solve for an unknown works. And that's based on equal unit rates and cross multiplying. Okay, so now let's use that idea to cross multiply to solve for an unknown. I always like to start with the side that has my x on it, so I'm going to multiply from the bottom up. This is 10x is equal to 4 times 9, 36. And when you divide both sides by 10, yes, you should show your work. You got 3.6. All right. Again, if that was too fast, you're just going to back me up and listen to it again. This time I'm going to do 2y is equal to 34 times 5. Now, some of you might be saying, do I have to circle those? You actually don't have to. They're called the means and the extremes of a proportion. I'm circling them right now because it's the only way on video to demonstrate what the heck I'm doing. But also it helps if kids don't understand. But as you start to understand, you can drop the circling of those things, okay? That one's 85. Ooh, the last one I think is the easiest yet, but I want to show you that I could do this side first to get 3n, and then multiply these two. 21 times 7 is 147, and to get n alone, I'm going to divide both sides by 3 to get 49. Okay? All right. Awesome. Now you know that we just do the calculations because it helps us as we lead into what actually happens in real life. And so I want to refer you to some things we do that help us. We always set up a labeled proportion. So I start with words, what I compare in words, and then I set up that cross products being equal to each other, those two ratios, and then I cross multiply. So the air temperature rose 7 degrees for every over 2 hours. That right there tells me that I'm comparing degrees to hours. And you do need to write that because I'm telling you, as things get more difficult, that is going to be helpful. Now to start my proportion, I'm going to plug in the 7 degrees over 2 hours. And I know I'm going to have another ratio. Write and solve a proportion to find the number of hours. That's what you're looking for right there. So if we were to have a let statement, we would let x equal number of hours, okay? And look to see where hours are. Hours are in the denominator, so x is going to be here. How many hours is that at this rate for the temperature to rise 13 degrees? Again, I want to point out to you the reading of directions to round your answer to the nearest tenth. Now that you've taken this and made a proportion, we can cross multiply. 7x equals 26. Divide both sides by 7. 26 divided by 7 is 3.7142. So I'm going to round to the nearest tenth. X equals 3.7. What was I looking for? I was looking for hours. So this is 3.7 hours, almost 4 hours. Okay? For every 2 left-handed people, there are about 15 right-handed people. So it looks like I'm going to compare left-handers to right-handers. If there are 36 students in the grade level that are left-handed, predict the number of students who are right-handed. So I don't know how many here. Oops, I forgot this part. 2 left-handed to 15 right-handed. So it doesn't matter which side the ratios are on, because either way you're going to cross multiply. Something I don't want you to do is this. I don't want you to go, okay, multiply those and then multiply those, because that x in the middle looks like perhaps you're wanting to multiply them and you're actually not multiplying them. So either don't do anything or circle them. Okay? So that gives us 540. We're going to divide that by 2, and that gives us 270 denominator, right-handed students. Right-handers, I'll call them. Okay. Okay, next one, and this is the last one today. The ratio of boys to girls at a movie theater was 37 to 43. So it appears that we're looking for the ratio of boys to girls. I say appears because keep reading. About how many kids would be boys out of 300 total moviegoers? So here's what I need you to do. I need you to use your little eraser, right? Because we have erasers on pencils. We want to know how many boys to the total number of moviegoers. All right, well, the ratio of boys to girls is 37 to 43. Remember that order matters. So if boys comes first here and girls comes second here, then the numbers are the same. So 37 is boys and 43 is girls. But what would my total be? Hopefully you said you have to add 37 and 43 to get 80. How many boys would that be out of 300 moviegoers? Cross multiply, 80x equals 300 times 37, which is 11,100. I don't use commas when I'm calculating because they tend to look like ones or something weird, so I just leave them out. And this is 138.75. That 5 would tell this to go up to 8. Now let's think about this. It says how many kids would be boys. Can you have 138.8 boys? You can't. And this is an approximation. So in this case, it would be okay to say there are approximately, I'll do it over here, there are approximately, it helps to be able to type, 139 boys. Okay? All right. So that's today's notes. Thanks for coming. Oh, you now have to do the homework 5.5.